Our next topic in surface chemistry is Hardy-Shikell's rule. This rule says the ions carrying charge opposite to that of Sol particles are effective in bringing about the coagulation of Sol. The first point of this rule is when we are taking the colloidal Sol, suppose the particles of Sol, they carry positive charge. To this Sol, when we add electrolyte, like we are adding electrolyte NaCl, coagulation, that is precipitation of this colloidal Sol will take place. If it is positively charged Sol, then the negative ions of this electrolyte, they will cause the coagulation of this colloidal Sol. The ions carrying charge opposite, to that of Sol, particles are effective in bringing about the coagulation of Sol. The particles of electrolyte which have a charge opposite to that of the colloidal Sol, they only can bring about the coagulation of this colloidal Sol. Second point of this rule is greater the valency of the coagulating ion, greater is its power to cause precipitation. For example, in this case, negative ions of electrolyte, they are causing the coagulation of this positively charged colloidal Sol. And if we have choice of electrolytes like FeCN6 4- with these negatively charged ions which have a valency of 4-, this will have the coagulation power more than this negatively charged ion, and this has more than the sulfate. Sulfate has more than that of the chloride. So in place of chloride with 1 valency, if we take electrolyte with sulfate having 2 valency, or electrolyte with phosphate having 3 valency, or electrolyte with the negative ion with the 4 valency, then greater the valency of this ion, the ion that is causing coagulation. So in this above example, negative ions are causing coagulation. So more is the valency of this coagulating ion, greater is its power to cause the coagulation or precipitation. So there are 2 points of Hardy-Shikell rule. Next is coagulating value. What is coagulating value? The minimum amount of an electrolyte, this electrolyte that we need here, the minimum amount of an electrolyte in millimoles, normally we need it in very less amount, millimoles per liter of colloidal Sol required to cause precipitation of Sol is called coagulating value. So this electrolyte that we need in millimoles for 1 liter of sol to cause its coagulation, that value that we need, that amount that we need here in millimoles, that is called coagulating value. So this is about the Hardy-Schedule rule. Our next topic after this, emulsions. In colloidal sols, if both dispersed phase and dispersion medium are in liquid states, if they are in a liquid state, the colloidal sol formed is known as an emulsion. If both dispersed phase and dispersion medium, they are in liquid states, then the colloidal sol formed is known as an emulsion. There are 2 types of emulsions. First is oil in water, written as O/W, oil in water type emulsion. This means in these emulsions, oil is the dispersed phase and water is dispersion medium. Example, milk, vanishing cream. These 2 are examples of oil in water emulsion, where dispersed phase is oil and dispersion medium is water. Second type of an emulsion is water in oil, that is W/O type emulsion. Water in oil type emulsion, where water is dispersed phase and oil is dispersion medium. Example, butter, cream. After knowing the 2 types of emulsions, next is a term, emulsifier. So emulsions of oil in water, they are unstable, and the 2 layers, dispersed phase and dispersion medium, they separate if we leave it for some time. So stabilization of this kind of emulsion is required. And how this is stabilized? By adding an emulsifying, third component is added here, that is emulsifying agent is added here. This emulsifying agent, around all the particles of this emulsion, dispersed phase, they are forming a film around every drop. Around every drop of this dispersed phase, they are forming a film, emulsifying agent, and hence prevent the drops from combining with each other, because there is a layer of emulsifying agent around these drops, so drops will not come in contact with each other and they will not combine. Now, example of emulsifying agent for oil in water emulsion is protein, gums. These are examples of emulsifying agents which are used to stabilize the emulsions of oil in water. After knowing emulsifiers, next term is demulsification. Demulsification. D means removal. The process of separating an emulsion into its constituents. Constituents means the process of separating dispersed phase and dispersion medium is called demulsification. And how this is done? This is carried out by heating an emulsion or by doing its centrifugation. By centrifuging, by heating, we can separate the two components of an emulsion. So this is about our topic, emulsions. Now next we have colloids around us. Examples of colloids which are around us, like blue color of the sky. Why the color of sky is blue? The dust particles which are suspended with water, dust suspended with water in air, they scatter the blue light. They scatter which light of vapor? They are scattering the blue light. And this light reaches our eyes and the sky looks blue to us because the dust and water suspended in air, they are like the colloids. So when the light falls on these, Tyndall effect, so the light scattered will be the blue light. And this light when reaches our eyes, then the sky looks blue to us. Next, fog, mist and rain. Fog and mist, they are formed when a large mass of air which has dust, is cooled down to its dew point. Then the moisture of air condenses on the surface of these. The moisture will condense and thus the mist and the fog will form. So when fog and mist, they are formed from the large mass of air which has dust. This large mass of air which has dust is cooled below its dew point. Then moisture of air will condense on these and hence they change to mist and fog. Like this, the mist and fog, they will form. Rain now. Clouds are aerosols. Aerosols means it is a type of colloid where dispersion medium is a gas, having small droplets of water suspended in air. In air, the small droplets of water are suspended. So here liquid is this and gas is air. This is a type of colloid. As these droplets of water, they condense. When they are condensing, they become big. And they become heavy and now they fall down as rain. So the small water droplets which are in air, when they condense, they become big. Now they are in colloidal range, they are heavy and now they fall down as rain. So sometimes the rainfall occurs when two oppositely charged clouds, they will meet. Sometimes the rain will form when the droplets of water which are there in air, they condense. And sometimes when two oppositely charged clouds, they will meet, then also there is rainfall. And artificially also we can have a rainfall. How artificial rainfall is caused? By throwing clouds. Clouds are colloidal sols. So when artificially on these clouds electrolyte is sprinkled. So when the cloud will come in contact with electrolytes, that is sol and electrolyte, there is coagulation. So when electrolyte is sprinkled over the clouds, then the clouds will become heavy and they fall down as rain, and this is known as coagulation. Next example of colloids around us is food articles. Many food articles like milk, butter, ice creams, fruit juices, etc. they are colloidal in nature. Next we have blood. Blood is also colloidal solution. It's a colloidal solution of albuminoid. So when there is bleeding, bleeding means blood is coming out, and that is a colloidal sol. Blood is a colloidal sol. So when there is a bleeding, if we add electrolyte on it, if we put electrolyte on this bleeding, what will happen? The blood will coagulate. The coagulation of blood takes place, and for this purpose normally electrolyte used is FeCl3. FeCl3 is used to cause the coagulation of blood. Next example, formation of delta. How deltas they form? Where the river water meets the sea water, there we get the delta formation. River water, this has clay particles in it. There are clay particles in it which are colloidal in nature. These clay particles in river, they are colloidal in nature. And here, for example, we have sea. We all know sea has salts in it, and salts, they are electrolytes. So where the river water is meeting the sea water, there these clay particles which are colloidal in nature will come in contact with electrolytes of the sea. So colloidal sol and electrolyte, there will be coagulation. Coagulation means these clay particles will start coagulating here. So when they coagulate here, there is a triangular bed formed here near the meeting point of river and sea. So this high risen bed formed here, the river water cannot pass through this, so it is now passing to the side of this, like this, it will flow. So this is in form of triangle, and we know in chemistry this symbol we use it for the heat. Triangular symbol is for the heat, or this is the delta symbol. That is why we say this formation of delta, because this triangle just looks like a delta only. This is formed by deposition of the clay particles where the river water meets the sea water. So this is formed by coagulation of the clay particles which are there in river. So these are some examples of colloids around us. Next we have a last topic of the chapter, applications of colloids, uses of colloids. First use is electrical precipitation of smoke. The smoke which is formed in industries, this smoke, before it comes out from the chimneys, this smoke, for example, this is smoke here, before coming out through a chimney, this smoke is passed through a chamber. It is passed through a chamber first of all, and then it goes into the chimney here. So in this chamber there are electrical plates. For example, in this industry, the smoke which is formed, smoke is colloidal in nature, it is sold, it is colloidal in nature. Let's say Here the Sol particles of smoke, they have a negative charge. So in this chamber, the electrical plates, they carry positive charge. So when the smoke passes through this electrical chamber, the negative particles of the smoke are attracted by these electrical plates. So when the negative particles move towards these electrical plates, they coagulate. Coagulate means now they start settling down here. The smoke particles will settle down here. The poison smoke particles, they are settling down here, and then rest of the particles which are not harmful, they are passed through a chimney. This is how electrical precipitation of smoke takes place, and hence the poisonous gases will not come into the atmosphere. The precipitator which is used here, this is called Cottrell. Name of this precipitator is Cottrell precipitator. Cottrell precipitator. Next application of colloids. Purification of drinking water. The drinking water has some impurities are there in the water. How these impurities are removed so that water is fit for the drinking purpose? The impurities which are there in the water, these are in a colloidal form. These are the colloidal particles. Impurities are colloidal particles in water. So water has these impurities suspended in it. These are colloidal in nature. These are made heavy. These particles are made heavy by adding electrolyte into this. The electrolyte added for this purpose is alum. That is a double salt. This is added into this. So when these colloidal particles will combine with electrolyte, what will happen? Coagulation of colloidal particles will take place. That is, these particles, they will become heavy and they start settling down here. That water is filtered now and is used for the drinking purpose. Next application of colloids is medicines. Most of medicines are prepared in colloidal form because it is more effective in a colloidal form, as they have large surface area in colloidal form. Example, Argyrol. This is a silver sol made from silver sol. This is used as an eye lotion. So it is an example of colloid. Then second is antimony sol, a colloidal sol of antimony. This is used for curing Kala Azar, that is a black fever. Then third example is gold sol. This is used for intramuscular injections. For intramuscular injections, gold sol is used. Then next example we all know is milk of magnesia. This is also colloidal in nature. It is used as an antacid, used for stomach disorders. It is used. Fourth application is tanning. Animal hides, the animal skins that we remove from the animal hides, they are colloidal in nature. And these hides which have positive charge, the hides which have a positive charge, they are soaked in tannin. Tannin has a negative charge. It has a negative charge. So what this one will do, this tannin will coagulate this positively charged animal hide. So coagulation takes place. And because of coagulation, this animal hide will become hard. It will become hard, and this process is termed as tanning. Making this animal hide hard is known as tanning. And how this is made hide? The animal hides with positive charge. They are soaked in tannin, and because of which the coagulation will take place and animal hide will become hard. In place of tannin, we can use chromium salts also. Chromium salts can also be used in place of tannin. So this is the fourth use of colloids. Fifth use, cleansing action of soap. That already we have covered up. Next one is photographic plates and films. The photographic plates or films, how these are prepared, the roll that we use in the camera, that film that we use in a camera, how this is prepared. It is prepared by coating over this. Simple glass is first of all taken. A glass layer is taken. On this, a photosensitive, light sensitive silver bromide, its emulsion is pasted here. In this way, the photographic plates or films are prepared. So what we are using here is an emulsion, that is we are using the colloids to prepare photographic plates and films. Rubber industry. Rubber is obtained from a rubber plant. The cuts are made in the rubber plant, and through those cuts a white color liquid comes out. That liquid which is collected, a thick liquid that is collected from the rubber plants or from the trees, that is called latex. The thick liquid because it is actually a colloidal sole. Now how we harden this liquid? To this what we add is an electrolyte. To this electrolytes are added and then its coagulation takes place. So rubber is actually obtained by coagulation of latex. Last use, many industrial products are actually in a colloidal form. Some examples are paints, inks, synthetic plastics, then rubber. Just now we have done rubber is also colloidal in nature. Graphite, that is carbon, lubricants, cement, etc. Many of the products that we use in industries or make in industry, they are colloidal in nature. So this is about surface chemistry.